Hey guys, welcome to our final exam review video for Standard 5.1 Interpreting Functions. This one is working on functions themselves as well as finding the domain and range of certain functions from their graphs. So this first part, where we are evaluating and solving functions, there are typically two pieces. One piece I'll ask you to find f of something, and then the other piece is when I'll ask you to find x when f of x is equal to something. So for this first one, this is the easier one. It's pretty soft. If I say to find f of 4, all you have to do is take this equation and plug it in for x in that equation. So if my original equation is square root of x plus 2, I'm going to put the square root of 4 plus 2. All right, and then all I have to do is calculate this. So the square root of 4 equals 2, and then that plus 2 is just already hanging out there. So my final answer for this part would be 4. Okay, so again, all we did was we plugged what they said, that was in the parentheses, in for x. Now the second part is a little bit different. You should recognize that because even the question itself looks different. This time we have to find x if f of x equals 5. Now up here, they told us that f of x equals root x plus 2. So we're going to go ahead and take that original equation and set it equal to 5 because they told us to set it equal to 5. Okay, and now we are on our journey to solve for x, to start getting x by itself. So the first step to do would be to subtract 2 from both sides. Let's try that again. All right, so on the left side, we are left with the root x, and on the right side, 5 minus 2 gives us 3. So now we have just one step left. We kind of did get the x alone, but it's kind of stuck in this square root sign, and we want to get rid of that. So in order to do that, we have to do the opposite of square rooting, which is to square both sides. So when you square a square root, you just end up with what's inside, which is x, and then on the other side, 3 squared is 9. And that is it. So basically, you just set your original equation equal to the number they tell you, and then just get x by itself. All right, now we are on to analyzing our graphs. I'm going to go ahead and change the zoom here so we can kind of just see it a little better. Let's do one more. Okay, so here we have this graph, x plus 2 squared minus 4. So you can go ahead and graph that on your graphing calculator. You can also graph it on Desmos. Here I've graphed it on Desmos. And we can see that the vertex is at -2, -4, and these are my two x-intercepts. I'm just going to go ahead and use those for my graph. So let's see. Put that there. Yeah, our two x-intercepts. All right, so I'm going to go ahead and try to draw a reasonable looking parabola, but it won't be perfect. Alright, whatever. So this is going to be our graph. So now let's take a look at these little pieces we have to find. First, the x-intercepts. So the x-intercepts are where we hit the x-axis, of course, which is this horizontal one. So this and this are my x-intercepts, and clearly those are at -4 and 0. So remember, the x-intercept should be written as points, though. So it's -4, 0, and 0, 0. Okay, x-intercepts always have a y value of 0. Next up, our y-intercept. Now the y-intercept is where I touch the y-axis. That also happens to be 0, 0. Anytime 0, 0 is one of the intercepts, it's also going to serve as the other one as well, because 0, 0 is on both the x and y axes. All right, the vertex we can tell pretty easily just by looking at the picture. You can also use the opposite of h, k method, right? H is 2, k is -4, so we know that our vertex would be at -2, -4. But otherwise, you can, again, just use the picture. Oops. All right. Now, our minimum is the lowest point on the graph, and for us, that happens to be the vertex. So that's also going to be negative 2, negative 4. Now the maximum is the highest point on the graph. So for that, we have to look at how high this graph will ever go. For us, this graph will actually go on and on forever and ever in the upwards direction towards infinity, and so there actually is no maximum. So we will write DNE for it does not exist. All right, now up next is domain and range. For domain, we focus on x values. For range, we focus on y values. So when we're finding the domain, you ask yourself, okay, how far to the left will this graph ever go? Well, because this is extending on and on forever and ever in the left direction, it's going to approach negative infinity. So that means our left bound is going to be at negative infinity. And on the right side, it kind of does the same thing, right? It goes on and on and on. It's going to go farther and farther to the right till like the end of time. So that side is going towards positive infinity. This is because left indicates negative numbers, just like you can see on the graph, and right indicates positive numbers. Additionally, never put a bracket on infinities. Those always have to have parentheses because you can't actually reach infinity. All right. So for range, this is now lowest to highest. The lowest y value on this graph is right over here, so that's got to be negative 4. And the highest y value, well, remember, this thing is going up and up and up forever, and it goes towards infinity. So again, infinity receives a parenthesis, but negative 4, since it's like an actual number and a legitimate point on the graph, it receives a bracket. All right. Lastly, we have line of symmetry. This is the line that literally cuts your graph in half. For us, that will be this line right over here. So that line is an equation. Remember, it's a line of symmetry, so we need to write it as the equation of a line. Line of symmetry is always going to be x equals, because it's a vertical line, and it's touching the x-axis. And then it's going to be the number at which it does touch the x-axis. So for us, it's going to be negative 2. Another way you could think about it is that it's also always going to be the x value of the vertex. Yikes. All right, and that is all. You will have to do all of this on the final. It'll be a question very similar to this. Okay, I have one more example of domain and range. So here we have, this is actually a radical function. So for domain, how far to the left does my graph ever go? Well, the farthest left x value this will reach is negative 3. The farthest right it will ever go, well, it goes on forever and ever in the right direction, so it'll go towards infinity. Bracket on the number, parenthesis on the infinity. All right, and range is low to high. So the lowest this will ever go is actually like negative infinity, because this graph, notice how it's like going downwards. It would go on forever and ever and ever and get lower and lower and lower. So it's approaching negative infinity. And we always go smallest to highest, so negative infinity has to come first. The highest y value we'll ever reach is going to be this positive 3, because we never get any higher than that. So again, parenthesis on the infinity and bracket on the regular number. Okay, I hope this helped. Please let me know if you have any questions. But yeah, happy studying.